So, good afternoon, everybody. I hope you can hear me. If there are any issues, if you don't hear me, please let me know. I will also write on the chat. So, I would like to welcome you and thank you for taking the time to join into this joint webinar with AmBIENCE and the NOVICE project entitled Accelerating the Transition to a Low Carbon Future Through Innovative Business Models and Price-Based Service Contracts. So, a few words about the premise of actually both why these projects exist and also the goal of today's seminar. So as plenty of you may know, the clean energy package for Europeans has set the goal of reducing the greenhouse emissions and with specified targets of approximately 32% reduction of 32% increase in both energy efficiency and renewable energy. How this is done is a complex issue, and both projects represented here, try to tackle this by combining flexibility from energy resources with energy performance contracting. In particular, a few words, just a few words about the AmBIENCe project, which aims towards accelerating the decarbonization of buildings and districts by utilizing flexibility from electrified heating and cooling sources via demand response products, with the goal of transitioning this consumption towards time periods during the day where generation is emission-free. NOVICE, on the other hand, not on the other hand, NOVICE, sorry for that. NOVICE promotes the development of enhanced energy performance contracts and MOUs between NESCOs and aggregators, which by combining energy efficiency and demand response can both enhance energy savings while maintaining comfort of occupancy. Now, so these were some short words about the two projects. Now, the people that will represent these two are from the side of the AmBIENCe project, Mr. Maarten de Groote, who joined VITO in 2019. He has more than 15 years of experience in energy efficiency, sustainable and smart buildings, and he currently coordinates the Positive Energy Districts program and manages several project teams for public clients. From the side of the NOVICE project, Mrs. Jo Southernwood, apologies, also has more than 10 years experience on the field of energy efficiency and low carbon technologies. And she's currently, and she is the coordinator of the NOVICE project. So, in order to not abuse my time as the moderator, just a few words after me. Mr. Maarten will present the AmBIENCe project. Subsequently, Mrs. Southernwood will present NOVICE. And at the end, we have specified a 15 minutes time for Q&As. So I would like to encourage everyone to write their questions via the chat. There is a question mode, and I will collect all questions and direct them to the appropriate speaker at the end of this webinar. So, without further ado, I would like to give to pass on the words to Mr. Maarten to continue with this webinar. Thank you.
Thank you, Dimos. And I'm reading through the chat, and I see that people are problems hearing. Can maybe somebody respond in the chat box if you do hear, to know if it's our system or a system of the others? Okay, so I think, okay, everything is clear. Thank you and good afternoon, and I will proceed. So I think those that can't hear us, it's rather their system than ours. So I'm going for to the next slide. In real life and in lockdown mode, I'm less serious and I'm on the picture, but nevertheless I will shut down my camera to not to be disturbed by my own image. And I will proceed then just as such. So from the AmBIENCe project, thank you, Dimos, for giving the floor. And as mentioned, it's a presentation of two projects, being the AmBIENCe and the NOVICE project, while NOVICE will be closing next month, if I'm correct. They will have a lot of research and relevant input to give. AmBIENCe is now started for a few months, so we are still in the first phase, but nevertheless, I think I'm quite confident we have some interesting stuff to tell. But before I go into the deeper content, maybe a quick introduction on energy performance contracting, where we all know that there is significant cost and therefore also opportunity and potential for savings during the operational phase of the building. We also do know that most building owners and users are no energy experts. And energy topic is becoming more and more complicated because it's not anymore only about heating your building, but it's also about how can you react to the energy market, which is a complex given. So in that perspective, there is a concept of energy performance contracting, where you actually give or outsource that expertise. The visual on the left, bottom left, is a general overview of how energy performance contracting or EPC works, where the blue square that you see here, blue surface, are actually the baseline energy costs. While from a certain moment you do investments, you have a renovation, and you actually have energy gains. And so the investment is actually being refunded by the gains over a certain contract duration. And after the contract ends, basically you have a lower energy bill and your costs have not been increased. So that is a general overview of what EPC stands for. As mentioned, you outsource it, and it goes very much from optimization of your heating system, of your installations, but it also includes deep energy retrofit. The experience on the market, however, it shows that especially private building owners, they opt rather for a fast return on investment, which means that really the deeper energy retrofits are often not taken into account in ESCOs. And that's maybe what I find a pity in this given. At the same time, that's why it's very relevant, ESCO and EPC systems for public buildings, because they can go to a very long return investment. So you shift your risks, but you also include, or you could include, the financing and make it holistic, even including the maintenance aspect in the whole contracting, so that you actually source out all energy related aspects to a third party, quite often private partner, which is then the ESCO, Energy Service Company. It is a flexible system in the perspective that there's different approaches possible. You see here the three main categories, from guaranteed savings, shared savings, and energy supply, which are the commonly used systems across Europe, where a guaranteed savings model, which has more or less half of the European market. Basically, the ESCO provides a savings guarantee to the client. So this is a hard contract. And it's the client that actually has a loan with a bank or a financial or investor. And so based on the guaranteed, you are paying back the bank. Then the shared savings model is where actually it's the ESCO that foresees the financing. And therefore, your ESCO is actually financed through the obtained savings. So that is the main difference, is that either the ESCO or either the client stands in the middle. While the energy supply contracting, basically an ESCO picks up all responsibility for the energy related to the building or buildings, and just make sure that there is a certain outcomes that is needed by the client. So the client needs a certain temperature in the building, the client needs electricity for its application, the client needs maybe electricity for a production line. If this electricity is renewable from installations on the roof, or if it's from somewhere else, that is up to the ESCO in that case. So that was an introduction on energy performance contracting, while at the same time we see in buildings a clear trend on digitalization and smartness. So our buildings are on different levels becoming smarter and digital. And a clear example is that with active management of your building, you really can have significant emission savings in a very cost efficient way. And we see numbers from 5 to 30%, for example, for space heating in residential buildings. So given that the investment there is quite limited, it's a very high return investment. That's one. Second, buildings are becoming smarter as well. For example, buildings can react and answer to the needs of the grid. I will tell you right away, give you an example on that. And third, buildings are becoming more digital. You're having sensors, meters, you have ICT to improve comfort and security. So it goes beyond energy. For example, my grandmother, she has a kind of a sensor around her and in her house that if she falls, that there's an alert that help comes her way. And this aspect of this digitalization, it opens a lot of business opportunities to support measurement and verification that we can link to energy performance contracting. So if we go back to the aspect of energy flexibility to have a good understanding of what it actually means. On the left, now you see a visualization of a traditional heating system, which basically switches off and on the temperature that it reaches. So you ask for a temperature of 21 degrees, your heating system heats up. When it's there, it's shut off until you reach a certain comfort limit and it's being put on again. While if you go to a smart control system, your heating switches on and off whenever it wants, as long as the comfort is not compromised. And it is exactly that is energy flexibility. So the fact that you can play between a certain comfort zone with your heating. And with buildings, for example, you can capture the heat in the walls, and the better they are insulated, of course, the better you can capture the heat. So this is an issue that becomes more and more relevant with the energy market we're part of today. So very enigmatic image there, and it's because you know who I am right now, or you should, or you're supposed to know. I don't know who you are, and therefore we have built in a small survey, which I invite you now all to vote. You should see it right now. I think there should be a button for you to choose. So from which organizations you are, you can take one choice, which EPC model you're most involved in. I just gave there the explanation. If you are not aware of any EPC model you're involved in, just put not applicable. And if you're having, or if you're managing a specific building or working in built environment, which system do you use to acquire energy flexibility in your heating of a building? Is it traditional on-off, smart control, response related, smart control, non-demand response, or not applicable? So I'll give you a thought. We have on this moment 90 people present. From those 90, 10 are probably taking care of the kids. So that's 80 that we need to achieve. 5 of them are taking care of the cat, so that's 75. So we wait a little bit more to have some more responses, and then I can take a zip at the same time. Good. So many other companies, R&D, many are not involved in EPC model. Some, most until now, on the guaranteed savings model, which actually is in line with also the deviation on the European level. And then interesting to see that there is more or less equal reply between the smart controls. Good. I think if we reach 50, so one more, then I will shut down and end the voting. Well, there we are. And I will close the voting right now. Thank you very much. Good to know. And I will switch back to my presentation. Good. So I want to proceed with a specific example. In this case, we have a single family house, typical house in Flanders, where there is the original situation. There is no wall or roof insulation, still single glazing, so very inefficient building, but unfortunately quite typically still. If we insulate the building envelope with a cavity wall, we have 12 centimeter mineral wool and in the roof and double glazing. We achieve around 60% savings on the heating. On the electricity, we don't have savings there, of course. If we do then a step further and we install PV and a heat pump, we see that, of course, our gas usage drops down to 0, while our electricity consumption peaks, and we have a total of around 1,000 kilo CO2 compared to the original 7,000. So that's really a significant change. What is interesting, of course, here as well is that we have injections on the net from your PV, so we have savings somewhere else. And as mentioned in the introduction by Dimos, I'm working a lot on the concept of positive energy districts. I believe very much that more and more we have to approach buildings not from single buildings, but from district approach or even the community approach, that you can install photovoltaics on a location where it suits best within a district approach, so nearby. And there, I think I'm sure that European legislation is also moving in that direction. And then, so the last step is that if we add on the PV and heat pump installation, if we add their active control of your heating in your domestic hot water, you see still a significant drop of around 30% of the previous step, where it makes interesting that we also have less injection on the grid, and we can consume more electricity of our own production, and that is even without a battery storage system in the house. This is also with a relative low carbon intensity. It's the Belgian numbers, which are low carbon, mainly, unfortunately, not due to renewables, but mainly due to the nuclear. But so it shows where we stand, and of course, the higher carbon intensity, the more impact, of course, your active control can have as well, because you can consume when there is, for example, not renewables available on the net. So as you see, there is a considerable savings on the active control. There are clear benefits, but given the number of savings in euros and in values, it is not sufficiently to cover it as an individual building. And from that perspective, aggregation is appropriate and even necessary from an energy performance contracting perspective. I want to show you also how the energy market is reacting, and that's directly related to the flexibility capacity of the building as such. This is some pictures I got from a tweet yesterday, where there was predicted to be, for the 19th of April, to have negative prices on the spot market. So it's maybe very small, but you see the 0 line is here. So between 2 o'clock and 4 o'clock in the afternoon, we were going to expect negative prices on spot market. But what we notice is that in reality, on the day itself, we had much less sun than predicted. The gray upper line is the day ahead forecast, while the orange line is measured and upscaled production, which is about 1,000 megawatt less than predicted. So this created a big gap. And if you then see the Belgian overview of production, where you see that the yellow square is a nuclear power plant, which did not react at all to this need. And the fact that there was hardly a reaction from traditional power plants made that the imbalance market was really going crazy the 19th of April, with prices, and as the blue line that you see here, up to more than 350 euro per megawatt hours, which normally ranges between 30 and 40. So it's factor 9 to 10 on the price of the imbalance market. I think that's very interesting to see. And in the past, buildings were not able to react, but now they can, and that's what is relevant. I also just saw a tweet earlier today that actually on this moment we're having too much production in Belgium of energy, and it's the windmills that are being shut off because a nuclear power plant can't be shut down. So if you would have much more demand response capacity, you could react on that. Good. So what we aim with, I like it. What we aim with AmBIENCe is to combine actually the energy performance contracting business case with the innovation behind the demand response. It is very interesting for us because it's two different worlds. You have different technologies, you have different business models, but you also have different end customers profiles, and so on. But we see that, or we are convinced that there is a double opportunity. In first is that EPC really could or should support the uptake of demand response, and therefore a more sustainable energy supply and well, society as a whole. That's one. And second, at the same time, EPC is a very promising business case, but it's not very well. It does not have the impact it could have yet. So maybe this demand response could help to increase the business case there. And then it is exactly on this intersection that we want to create a new concept. And it is this new concept where we actually add three dimensions to the existing EPC. So first of all, we want to include demand response services, as mentioned before, but we also want to see if this makes it we can tailor EPCs to a broader scope of buildings. And there, for example, residential are difficult to capture. And as mentioned before, if we could extend the scope of EPCs to an aggregated or a group or clustered amount of buildings under the same concept and related to the energy communities ID. Voila, for there the new concept. So where is the business value? The visual here shows that we can have different types of reacting to the market. We can have like load shedding where we only move the capacity to a lower amount. We have a day ahead where we shift the load, or we can have a very dynamic and implicit reaction and load shaping. And so there, the business value for end customers, and that's where I really want to stress and put attention on, is that yes, there are cost reductions because you avoid higher energy prices, as mentioned. That's one. Second, there are additional revenue streams. If, for example, you can arrange your PV that you consume more yourself than you put on the grid, you have additional revenue streams. But the third one we often forgot is that as a building owner or a building user, you have a much better understanding of your consumption patterns. I'll give you a concrete example. I was working on active control of shopping centers. And what was noticed actually when scanning through their consumption patterns is that the cleaning services who operated at night, basically they put out lights on the whole building, not only on the zone where they were cleaning. So these kind of things you can easily take out when you have a good understanding of your consumption patterns. Then to get back on where we want to go with AmBIENCe is that we, as mentioned, extend the EPC contracting to demand response. We want to make it available to a broader range of buildings. I mentioned that as well. But what is important here is that we need to foresee a measurement and verification methodology for the operational phase. Because this is the key, and I will give later a slide on that. Because if we don't have a proper measurement and verification protocol or methodology for the demand response, we cannot foresee a certain guarantee and business agreement or contract between the ESCO and the building owner. Of course, we have engagement with different actors, and we are testing this methodology in 2 pilots. What we did also, we are mostly involved in Italy, Belgium, Spain, and Portugal, and we analyzed the market of EPC, demand response, but also what are other enabling factors or barriers on level of legislation or financing. And we noticed that on level of EPC, Italy is the leading from the 4, with Belgium doing well, while Spain is very promising, but we're waiting a little bit to see what's happening, and Portugal still some work to do. On the stages of the demand response, we see that Belgium is leading, but that Italy is doing well, and Spain and Portugal has some work to do. And then on enabling factors, again, Italy and Belgium are doing quite okay, and Spain and Portugal still have, again, some work to do. So that makes it for the business model that we foresee under AmBIENCe. Italy and Belgium is a semi-mature market, while Spain and Portugal actually is more difficult entry market, but there is then maybe more our job to provide guidelines on in which steps to undertake. As mentioned before, on the measurement and verification, a small explanation on that is how it works. The blue line here, what you see, is the energy consumption or the demand of a specific building. The line here is where you have the investment and the measures being taken out. And so the green line is actually the new measured energy. While if you wouldn't have a measurement and verification protocol, basically you could say here at this moment, like, hey, we're actually consuming as much as we did in the beginning. So we need to track on what's happening there. And to do so, we need to track not only on the standard measurement and verification protocol which already exists, but also on including the demand response aspects. And therefore, we need the high time resolution monitoring, that's one. But we also need to see what are the routine and non-routine adjustment factors for this methodology. Routine is we know more or less the climate over the months, what it will be. But for example, if there is an increase in employment or if there is the crisis we are currently passing through coming up, we cover that under the non-routine and how is that related to demand response aspects. So that is the challenge for us to cover. And then to conclude my presentation, is active building management the silver bullet for energy performance contracting? I think we have to see it there as rather different layers. And so with energy performance contracting, you can foresee a lower energy consumption, you have decreased energy bills, you have higher comfort and well-being. And on this last point, I want to stand still for a moment in the situation we are now. I think now the people staying at home in healthy buildings that they feel comfortable with, the value of that is really becoming very clear. Also thinking about the hospitals, the better they are, the more good you feel there, the better, and the value of that is increasingly important and effective important. We have a guaranteed performance with secure building operation, and then what we then say in our story is that the improved business case through your flexibility is actually the additional layer of opportunities. So as an ESCO, when you sell or want to provide your service from active energy performance contracting to clients, it's a whole package that will do the job and not one specific item of this. So with that, I want to conclude. Also want to point out that partners are from Spain, Italy, and Belgium, and that we have a website, of course, where you can also register for the newsletter and keep up to date about what we are producing. So I thank you all for your response. I see that you're now with 78. That's a magic number. That's my birth date. And with that, I pass a birth year. Sorry, the floor to Jo.
Thank you for that presentation. Good afternoon, everyone. It's really nice to see so many of you online today. My name's Jo Southernwood, and I'm a Senior Research Engineer at the International Energy Research Centre. We're based in Cork in Ireland, and I'm the coordinator for the NOVICE project. So you've just heard from Maarten about some of the potential benefits of combining energy efficiency with demand response through EPCs. Well, NOVICE has been trying to do exactly that for the last 3 years, and we're now coming to the end of our project. So what I wanted to do this afternoon is talk to you about some of the key results that we've found from our research and present to you a couple of case studies on the interesting findings that we've had from particular buildings and particular sites that we've been looking at in the course of our research. So you've already heard a little bit about the EPC model, so I won't spend very long on this, but just to briefly recap, in a traditional energy performance contracting model, there are many advantages for this type of service. The first one being that the client doesn't necessarily need to provide any upfront capital from for the energy efficiency measures themselves. Often the ESCO or a third party can provide the upfront finance for the capital costs of the measures, and then that loan is repaid and recovered through the energy savings and reductions on energy bills. One of the other key features of an energy performance contract is this idea of the performance guarantee. So it's the idea that the ESCO will guarantee to the client that they will achieve a certain level of energy savings and in some case a certain return on their investment. So what that does is it moves the operational risk away from the client and towards the ESCO, and it's now really the responsibility of the ESCO to make sure, it's in their interests to make sure that the energy savings that they predicted are achieved in reality. And so for the client, that's a very risk-free way of implementing energy efficiency measures and upgrading buildings. It also means that there's only one contract that they have to manage. So they only manage the contract between themselves and the ESCO, whilst the ESCO handles all of the other parameters through from financing and subsidies to consulting, engineers, installers, the technology suppliers, plus the measurement and verification of those energy savings once they've been implemented. So from the client's perspective, it's a much easier contract to administer because they don't need to become experts in all of the different energy saving technologies. And as a result of taking this whole building approach, you can, in theory, achieve deeper renovations because you don't just look at the lighting or just look at the HVAC systems. You now take a whole building approach and implement a package of measures that's most suitable for that particular building. So on paper, this sounds amazing, and it seems like a great way to renovate buildings. In practice, we know that actually renovation rates around Europe are still quite low, and that the energy performance contracting model is quite prevalent in some countries, whereas in others, it's not taken off at all. So, for example, Italy has quite a buoyant EPC market through the white certificate scheme that they implemented there, whereas in Ireland, we're still quite a young and immature market with only 2 public sector EPCs in operation to date. So let's take a look at why that is. There are several barriers to EPC. The first one being is that they're just quite complex contracts. It's quite difficult to have a contract that includes third-party financing, performance guarantees, measurement and verification. All of those things are complex, and that makes them difficult contracts to sell to clients. That in turn means that the cost of procuring such a contract can be quite high because it takes a long time to go through the sales process. What we also find is that EPCs tend to have long durations, and contract lengths of 5 to 15 years are very common. I've even seen EPCs up to 20 years in length. And this is partly because of the whole building approach that you take. You include energy efficiency measures such as insulation or upgrades to building fabric. Those tend to be more expensive with longer payback periods, which leads to EPCs with a long duration. What that means is that we often find EPCs in the public sector because they know they're going to be around for some time, and they know that they're probably going to be in the same building for the next 10 to 15 years. However, it's a barrier to private sector becoming involved in these types of contracts because they're looking for paybacks, certainly within 5 years, often within 3 years. So it doesn't lend itself so well to the private sector. In terms of obtaining finance, what we've seen in our research is that it can actually be difficult to obtain finance because the loan itself tends to be secured based on the client or the ESCO's credit rating rather than on the validity of the technology that's being installed itself. So there's a bit of miscommunication between finance providers and those companies that are delivering these energy saving measures. And finally, in different countries, the level of government support that's available varies quite significantly. So there are all these barriers to EPC. Now, what NOVICE is trying to do is to take energy performance contracting as a business model and find a way to make it more attractive to a wider range of clients, so that we can really drive up those building renovation rates in Europe through using this model. So in brief, what we're trying to do is include not only energy efficiency measures, but demand response services through our EPC as well. So on the screen now, the bubbles that are in blue represent your traditional EPC contracting model. You take some finance, you implement energy efficiency upgrades, they achieve some energy savings, and those savings go towards repaying the finance. Now, what we often find with energy efficiency upgrades is they often include upgrades to building controls that make your building smarter. And if you have a smart building, what that means is that it can respond to the needs of the occupants themselves, but also to the needs of the grid. And in doing so, by providing those services to the grid, you can access another revenue stream through receiving payments from grid operators for those demand response services. So that's the NOVICE model in brief. So if we take a look at this EPC model again in light of the NOVICE model, what we see is that it becomes an enhanced EPC. So from the client's perspective, nothing changes. The client still only has a single contract with the ESCO, and the ESCO still handles all the same elements that it did before. It still provides a performance guarantee. But what it also does now is the ESCO has a relationship with an aggregator. And in this case, what I mean by that is a demand response aggregator. So an organization that gathers together all of the flexibility from many different buildings and offers that to a network operator and receives a payment from them for doing so. So the ESCO remains a single point of contact. They now receive a second revenue stream through demand response. And what we have is this memorandum of understanding that now sits between the ESCO and the aggregator and governs that relationship. So in NOVICE, we looked at these contractual elements in quite some detail to try and identify what needs to change contractually to make this model work in practice. And so from the EPC side, the EPC talks about what is guaranteed. So in a typical EPC, the energy savings and the cost savings are guaranteed. And that's because you can quite accurately predict what the energy savings are going to be when you implement new technologies. Now, the complexity comes when you introduce demand response into that. What you don't know is how many demand response events there will be each year, what the duration of those events will be, how frequently you'll be asked to participate in those events. And so it becomes very difficult to predict what the revenues might be from demand response. So if you can't guarantee the revenues from demand response, there must be some other way to include some kind of performance guarantee within the EPC that covers that element. And what we decided is that what you can't guarantee the revenue stream, but you can guarantee things like the thermal comfort parameters. So for example, if the building typically operates between 19 and 21 degrees under normal operating conditions, the EPC might choose to include a clause that says that during a demand response event, that temperature range can drift to, for example, between 18 and 22 degrees to give that extra level of flexibility while still providing an element or a level of performance guarantee. What we can also do is guarantee the operational availability. So a building owner won't want their site or their equipment to be completely out of action. They need to still be able to operate. So operational availability can be maintained within these types of contracts, and so can recovery time. So if you drift outside of those ranges during a demand response event, how long will it take for the building to recover and come back to its normal operating parameters? In terms of the MOU really governs who is responsible for each element of the contract. So who will be the client-facing party? In the contract template that we are proposing, it is the ESCO partner, but there may be situations where it's more appropriate for it to be the aggregator partner. The MOU also talks about how do you set the baseline? How do you make sure that both the ESCO and the aggregator agree on what that baseline is to avoid any contractual disputes later down the line? It talks about how do you split the revenues that are gained from demand response between the three parties, client, ESCO, and aggregator, and how do you share that information? So there's a lot of detail that's contained in the EPC and MOU, and they're available from the NOVICE website for anyone that's interested in that extra detail. So if we look at the charts for finance, you would have seen a version of the chart on the left-hand side of this in Maarten's presentation. What we're saying with NOVICE is that with this enhanced EPC, there's this additional revenue stream that's represented by the orange bar on this chart. And what NOVICE was really trying to find out was what's the value of that orange bar? And by how much can we reduce the contract duration as a result of including this second revenue stream? So what I want to do next is just take a look at a couple of case studies. I'm going to look at two. One is a case where this type of model has worked very well, and a second case where it hasn't worked so well, just to show you the difference. So we looked at an office with a data center to see if we could apply the NOVICE model. Now, our ESCO partner did an opportunities assessment for this particular site, and if they looked at energy saving opportunities alone, they came up with a package of measures that would cost just under 300,000 euros to implement and save just over 100,000 euros per year. So that's a pretty good package of measures on its own. If you also look at the demand response opportunities at this site, you can actually access an additional 20,000 euros a year of demand response and flexibility opportunities just by using the smartness of the building that comes about through the upgrade of HVAC and other building system controls. And what that does is it reduces your payback period by around 15% at no additional capital cost to the client, because in this particular case, the aggregator partner offers the equipment free of charge and recovers that cost through the first year of savings, through the first year of revenues. So in this particular case, it works very well. It's not a massive reduction in payback period, but if you were talking to a private sector client with a 3-year cutoff for their payback period, having that extra few months of reduced payback period, maybe up to half a year, could bring a project that was marginal into a project that becomes well within scope. So it's something that's worth investigating. The second case study I wanted to look at is a leisure centre. So we looked at initially a leisure centre in Dublin, and this was one of our sites because when we started the NOVICE project, they were already under EPC. with our ESCO partner. So we wanted to look at adding demand response to this EPC. Now, we couldn't do this in practice with a real demand response event because we, at the time, couldn't find an aggregator available in Ireland who wanted to participate. Remember, this was a couple of years ago when the market was less mature than it is now. So what we did was we simulated a demand response event at this leisure centre. And the way that we did that was to identify all the non-essential HVAC equipment and shut it down for 2 hours between 5 and 7 p.m. That's the busiest time for a leisure centre on a typical weekday. And we wanted to find out how much flexibility is available from this building, and would the building users notice the impact of this demand response event. So in terms of how much flexibility is available, this graph shows you the results from the event, and I'll talk you through it. On the horizontal axis, you have time, so starting at 3 o'clock in the afternoon, and on the vertical axis, you have the power consumption measured at the main electrical incomer for the site. Now, this particular site has a combined heat and power plant that normally provides the most of the electrical load for the site. So at 3 o'clock, 3 until 3:45, it was running as normal on CHP, and you can see that there's very little draw from the mains incomer. But to measure what the flexibility potential is, we had to first switch everything over to mains. So what we did was we ramped down the CHP until we turned it off at around 4:30 in the afternoon. That's the peak that you can see in the red period of the graph. And you can see that if the site didn't have a CHP, it would normally consume around 85 kilowatts at that particular time. At 5 p.m, we start our demand response event. We start to turn off all of the non-essential equipment, and you can see that for the duration of the simulated event between 5 and 7 p.m, the consumption drops to around 40 kilowatts. So that means that there's around 45 kilowatts of flexibility available. Now, for that particular site, that only amounts to around €400 worth of flexibility earned per year. It's around 0.5% of the total savings. So you can see that for this particular site, it's not such a good option. It doesn't result in the same level of savings as the office with data center. So what can we learn from the case studies? Well, we can learn that looking at demand response as part of the opportunities assessment and as part of an energy efficiency opportunities register could improve the business case for energy efficiency upgrades, but it really depends on the site. And what it depends on is the type of site that you've got and the type of asset that you have on the site. So those with large loads, those with some kind of energy generation, those with storage, those tend to be the ones that are more suitable for novice. Also, those that are able to participate in more than one flexibility program, so not just load shedding, but also frequency response, those tend to be more suitable and generate the higher revenues. And that really is dependent on the maturity of the demand response and electricity markets in each country. That can really have a significant effect on where you could do this. So not all countries have a market that's as open and as mature as the demand response market in Ireland. So this wouldn't work in every country around Europe. The final question that we wanted to answer was, what about the thermal comfort? What about the building users? So during this simulated event, we actually carried out a survey, a thermal comfort survey with building users. We had a control group that were surveyed before the event started, so none of the measures had any impact on their thermal comfort, and a test group that included people in the building during and immediately after the event. So we didn't tell the participants that we were carrying out an experiment on that particular day because we wanted to avoid biasing them and avoid the anchoring bias that might be associated with telling them that we had changed something. So we asked them a range of questions in order to gauge their satisfaction with thermal comfort, with temperature, humidity, and air quality. And the final question of the survey asked, did you notice a change in conditions during your time in the leisure centre today? And what we found was that overwhelmingly, the answer to that question was no. So most people didn't notice a change, which I think is important because we often come up against barriers where building owners say, well, we can't increase the number of complaints. We don't want to change anything because people will complain. So looking at these results in a bit more detail, some people said they noticed a change, but the particular group that's highlighted on the screen now, they were actually in the control group. So if they noticed a change, it wasn't anything to do with our simulated event. That was just under normal operating parameters of the building. So some people will complain anyway. What we also see is that only 2 people out of all of those surveyed identified a change, and it was the correct change, a change that we actually saw in the readings that we took. So I think this is an important message to give to building owners, to say, because I think often they think that it's impossible to turn equipment off, or it's impossible to give control of their equipment away. I think this shows that it can be done, and actually it can be done without increasing the number of complaints. So that's it from me. That's all I had to present today. Thank you very much for your time. Thank you very much for listening. I'm going to hand back to Demos now, who's going to facilitate some questions, I think. Demos, are you there?
Yes. It took some time to unmute. So thank you, Maarten. Thank you, Joe, for the presentations. So now a lot of questions have popped up in the chat. I will try to start with the first ones and go through them according to the time that they were asked. So I believe the first 3 were towards Maarten. So Maarten, one question that was raised was how do you align the different strategies you mentioned with discussions around circular economy? Can you hear us?
Video call bingo, you can put it as well. I was wondering if I could see the question written down somewhere, but if I understand well, is how to have the alignment with the circular economy, right? It's an interesting thought. I mean, I have colleagues working out on that concept. In this slide, I don't know if it's covered a lot. I think, of course, if it's about the building materials and the applications that you use, yes, there is definitely a link to cover. But how you involve it in your EPC, I maybe would like to leave the word to Jo if she has a feedback on that aspect as well.
Circular economy is an interesting one. I think that it's something that we're moving towards and will come over time. I think as it becomes more of a mainstream concept, we will move in that direction. Right now, yes, I can see that would be quite difficult to achieve, but I do see a move towards that that level of consideration in the future.
For everyone's convenience, I will pin the comment with the question in the chat window. I hope you will be able to see it as the first comment from now on. Okay. So the second question was asked by Claudia. A district approach seems to align with a grid-tier smart microgrid that aggregates across domestic and business demand. Would you agree?
From my perspective, well, it depends of how your energy vectors go. I mean, the district of your electricity grid versus district heating are maybe not the same surface or not the same geographical boundaries. So from that perspective, there's a different approach there. But I think no, very much otherwise, yes. Joe, maybe to you as well.
Yeah, I think it absolutely can. I think a district approach could align very well. We haven't done it in Novice, but in other projects that the IERC are working on, they've done some research on exactly that approach. If you take a small district of buildings that have this flexibility potential, is there a benefit to looking at the district as a whole and applying that flexibility on a district-wide level? And the answer from that research seems to be yes. So in the first instance, the district meets its own needs, and then it looks at the wider network to see how it can interact as a whole with the wider network. So yes, I think it potentially will be a way that this kind of market will go in the future, yes.
So, next question that actually raised a couple of more comments was, and Maarten also replied in the chat, does more variability in operating building system accelerate its aging? So
Yeah, to that I can also provide a response. So I asked you need to clarify a little bit what was meant with building system, and then Regis Meyer answered like HVAC or hybrid. And indeed, I think if it's about if active control can influence aging of, for example, heat pump or battery, most likely yes. But in that perspective, there are two solutions. One is complex, where you actually use a kind of an aging model to decide if you do a certain control or not. Right? So the question there is the value of that control worth it, the aging or not? That's a more complex. Or the simplified is that you set the kind of rules, kind of guidelines to decide when you take control and when not, and that way you actually mitigate the problem. At the other hand, if you have a variable operating system, you also have smart control, and if you have smart control, you most likely also have a better maintenance and a more detailed follow-up of your technical installations, which is then for the better of the system. So it's a kind of a double coin from there. Thank you. I don't know if Joe, maybe you want to add something there.
Well, the only thing I'd add is that yes, I agree. It potentially could accelerate the aging of building system equipment, and I think it's important in that case that the ESCO is involved, and it's good that these are combined in some ways, because then it becomes something that the ESCO can factor into their maintenance program and their ongoing management of these systems. So potentially it's another reason why it's a good idea to combine these, because that aging process can be factored in.
thank you both. So on to next question, which actually was ascertained by two attendees. Is it practical to assume that large numbers of people or organizations will give control of their essential systems to outside actors?
Yeah, it's a very interesting question, and yeah, it is something that we have come up against in the Novice project, that people are reluctant to give control, and I think that's in part because it's something new and because it's something that people maybe haven't come across so frequently in the past. I think that as it becomes more common, and we have more case studies of buildings that have successfully managed to do it without it impacting on building operation or thermal comfort. I think it will become more prevalent, but I think it's about reaching that point where it moves away from being an innovative new technology towards a more mainstream technology that will tip the balance towards large numbers of people being willing to give away control.
Mm-hmm. Yeah, maybe a quick add-on. I think it really relates to the services that you get in place. I think most of you have a smartphone, and when the battery of your smartphone is getting off, they ask you, can we lower down the functionality to have a longer battery life? I think we all say yes in that case. Now working all from home, imagine you have a service that has access to some of your data under very specific conditions and maybe controls your building that you don't lose your comfort. But the contrary, you get noticed when, for example, the indoor air quality is not sufficient anymore since you're working too much or whatever. So I think that it depends on the services that you get in response, and that's what I see when we are gathering more and more data. More and more of these kind of services come up. So I think aggregators will more and more provide certain services with a value for building users, and at the same time they can then have services relevant to play on the energy market.
Thank you. So onwards to a question by Ivan Scott pertaining the district that you also mentioned previously at some point. A district approach would presumably involve a virtual network, virtual power plant, with the virtual network paying charges for use of the physical grid. Is it? Yeah.
Yeah, for me, the question is not very clear, but it could be one approach to have the energy community managing the whole operational grid, and pays a kind of a cost to the DSO to have to construct actually the physical grid. Another maybe more likely approach is that DSO provides the operational grid management, for example, congestion and so on, but that the energy community or individual buildings actually are interacting with flex capacity to activate flex capacity to avoid problems. So
Yeah,
if I understand correctly the question there. Yeah, thanks, Joe.
yeah, and I think the network and the regulations that exist now are not necessarily the way that they're going to stay. This is a market that's constantly changing and fluctuating and being amended. So I think we'll see changes in the way that demand response is valued, that flexibility is valued, in the way that virtual power plants are deployed, in the revenue models. That's yeah. I think we'll see changes in the coming years.
Okay. So the next question I pinned was actually the one that ascertained for the second time the question about the control. So whether people would be willing to give control to outside organizations, and the question extends it by mentioning who would own the rights and the legal conditions. I don't know if you would like to comment something further on this, or we should move to the next one.
Sorry, it's the rights. Who owns the rights in terms of the district, the wider district? If I understood the question correctly, it's quite a difficult question to answer. I think in the district sense, again, one of the research projects that we've been looking at is using a blockchain tool, I suppose, to manage those energy flows. So to save one building maybe has solar panels and has excess energy, and they sell it to the building next door that needs to consume more energy. We're one of the research projects that we're involved in outside of NOVICE is looking at whether blockchain can be used as a method of peer-to-peer trading, which might help to solve some of those issues around who owns ownership rights, or who owns the energy, or who pays whom in this situation. I'm not sure if that's answered the question, but that's what I understood from it.
Okay. Thank you, Joe. And actually, one that I also think is directed to you based on the presentation is how are you simulating the demand response? I assume that the attendee was asking in relevance to the scenarios that you described.
Yes, absolutely. So in this particular case, we are simulating only a turn down event, so only load shedding. And what we did was our aggregator partner within the NOVICE consortium installed some of their equipment to talk to the BMS that was installed in the leisure centre. So the aggregator's equipment basically simulated receiving a signal from the network operator that then sent a signal to the BMS to initiate the turn down response. So what we actually did was control the parameters on the BMS. So we turned down all the equipment to its lowest operating parameters and change set points and operating parameters via the BMS in order to simulate the demand response event.
Okay, thank you. Now, apparently, I'm not sure if all the complete question is shown in the pinned comment. I will read it in any case. So some of the fundamental parameters for the LCC calculation, excuse my ignorance, I'm not sure what LCC means, have and are dramatically changing, e.g. inflation ratio, interest rate, energy costs, tax return. So how do you arrange and modify the standard set of parameters over time in order to compare alternative solutions in a cost optimality perspective?
This is an excellent question for Energy Invest, who is one of the partners, I think. They are not one of the speakers now, so I don't think that Lieven can react himself directly. Maybe he can react in the chat box. But I think it's also an interesting question for us to cover in a later moment, and that we will put on social media and maybe include when we send around the presentations. But Joe, maybe you can also reply directly on this, because I find it an interesting question. But yeah, go ahead. Sorry.
Yeah, no, it is a very interesting question around the different parameters. I think it's always the case that initially when you do the business case, you make some assumptions about what will happen to the cost of energy, what will happen to interest rates in the future. I have to admit that I'm not a financial expert. Our partner, Dual Assets in the NOVICE project, would be able to answer this question much better than I can. I think that what tends to happen is that ESCOs, when they're putting together their business case, tend to be cautious, and so they will build in some kind of safety factor to take into account the case where any of those parameters change in a way that would negatively affect their business case, so that they protect themselves against those exact rises. And that's partly why it's difficult to, you couldn't put a guarantee on demand response, because at the moment the market is changing so much and so regularly that you wouldn't know necessarily from 1 year or in 2 years' time that the same markets would exist and the same revenues would be achievable. So I think there's some built-in safety factors to the calculations.
Thank you, Joe. And Maarten, So next question, how do you see COVID affecting the business case for EPCs as presented here? If negative, what would be needed to drive momentum forward?
Very unfortunate but interesting question, of course. Well, I think there's a few responses possible. Of course, on this moment, we are all working from home kind of in a crisis situation, but at the same time, it definitely shows the need for increased not only comfort but also well-being. So the people that are in more comfortable and in better buildings, basically they survive better the crisis. So I'm quite sure that this will make that in future business models there will be more attention to, for example, having more natural light, having better noise, so less acoustic problems, having better indoor environmental quality on level of air perspective. And this can be done through monitoring, but can also be done through to surveys. And I think there are already existing service providers with these kind of services, but I think the importance will gain more on that. That's one. And second, I think more and more this will be visualized as well. So if you now have sometimes the most modern buildings, as user, you don't have any idea what the quality of the indoor air is. And I see more and more sensors and people coming with things of too much CO2 in the air and so on. So I think the visualization of an increased comfort and well-being will be more available. That's one. And second, I think that a lot of European and national and local governments, they will want to boost the economy. And what I see coming now from the political debate, also from the EU Green Deal, is that renovation of your buildings is an excellent investment for boosting the economy. And if there is limited funding available from that perspective, EPC business model is excellent to support a boost of the renovations there. So, Joe, I don't know if you have something to add.
I would agree with everything that Maarten has just said. I think there are a number of ways that it could affect the business case. Of course, when you do your calculations for an EPC, you have to make some estimate of the level of building occupancy. And right now, the building occupancy is zero in many sectors because no one's going into the office. Everybody's working from home. Going forward, I also think that COVID-19 will change the way we work, and it will, people have now discovered that it is possible to work from home. More people will want, I think, this is just speculation on my part, but I think it will drive more people to work from home more frequently, which will impact on occupation rates in buildings. I think it will drive the need for more personal conditioning of personal spaces rather than trying to keep the whole building at the same temperature. I think it will drive that need for the building to be able to respond quickly to the number of people in it and to where they are located to provide the right conditions in the right areas where people actually are working. So I think it could drive that forward. So I think it's a really interesting question, and I think it remains to be seen exactly what the impact is going to be on our working habits. But for sure, we'll need to be adaptable and we'll need to be agile in adapting to these changes.
Thank you both. So it's a quick note from my side. Since I see interest both from attendees and presenters, I go through the questions one by one, even though the time has passed. So I hope this is okay both from presenter side of view and the attendees. So I will continue to do so. Okay. So next question. Do you see demand response services as a form of energy as a service, or do you see them as different?
You can go first, Joe. I'm looking for my screen.
Okay, thanks. I absolutely see it as energy as a service. They're part of the same category, I would say. I guess demand response would be one of the specific cases of energy as a service, but it links very well to the idea of thermal comfort as a service, or heating as a service, or cooling as a service. There are many ways that you can offer this type of approach as a service offering rather than a product-based offering. And I think that we'll see more and more organizations moving to this type of model in the future, so that rather than just purchasing items or equipment or kilowatt hours, we'll see organizations moving to offering a service-based approach, and demand response will be one of those services that they offer.
Yeah. And then maybe a quick note from me on that side is that they are complementary, so they are definitely not contradictory. Because when you want to reduce costs or emissions, you can either reduce consumption and electrificate, or active control can be used. And so with active building EPC, you really try to find the optimal balance between to what level do you reduce the consumption and electrification, and to what level do you smarten your consumption. So it's really rather a strengthening and complementary than contrary.
Thank you. So last couple of questions actually. In an aggregation process, it might be difficult to identify only an enhanced EPC. Do you consider the possibility of a contract including a mix of enhanced DR and traditional EPC?
Yeah, absolutely. I mean, what I'd say is that the novice model has investigated one such approach, but there are many ways that you can do this. And really what we were trying to demonstrate within the project is that it is possible to look at these services together. So we have taken the approach that in the markets that we were specifically focused on, it would probably be the ESCO that was the main contracting party. They would probably be the client-facing party, but there's no reason why it couldn't, in theory, operate the other way around. So an aggregator has a client, they're already operating effectively with that client, and they know that that client has a desire to improve the energy efficiency of their building. There's no reason why the relationship couldn't go the other way, and they could introduce an ESCO partner to their client. So I think, yeah, the thing to bear in mind is that novice is an option. It's a way of thinking, but it's not a prescribed way of doing things. It's just opening up the possibilities, really.
Mm-hmm. Yeah, actually, I don't have anything specific to add on that. I want to maybe get back to the question related to the LCC and Lieven van Stralen, the financial expert or investment expert from AmBIENCE project. He says that if there is a long-term change to financial parameters, he would adapt them, but it's really based on long-term historical data. So if it's like a short-term variation, they would not adapt. So they look to averages of 5 years. I think that's a very specific reply to that question. Thanks.
Thank you.
And
Dimos,
I don't know time-wise, because I don't have too much time anymore. Maybe you can have like one or two final questions to conclude. Maybe.
We have exceeded, so I would make this my last question actually, although I do have three more actually, but I will make this last question because I can combine it. So in terms of measurement and verification, which methodologies have been applied for the presented case studies? And so there's also a question, a follow-up of this, I would say, if there are any guidelines available for the new EPC contracting model presented by you.
Okay, if I take the second one first, in terms of guidelines for the EPC model, yes, I can direct you to our website and a couple of our deliverables that look specifically at the EPC and how that might need to be modified and what kind of clauses you might need to look at. The same for the MOU. In terms of M&V, again, it's For the specific case study, so the Dublin site that I presented was already under EPC, and as part of that EPC, they would have come up with their M&V plan that looked at the building as a whole. So they would have projected out what the predicted consumption would be in the absence of measures. I wasn't personally involved in developing that plan, but in terms of that specific demand response event, because it was a simulated event, we were able to use the metering technology provided by Kiwi Power, our aggregator partner, to monitor what happened to energy consumption during that period and compare it to a day where no demand response event took place, to look at the difference between those two. The other site case study that I presented hasn't, it's an opportunities assessment rather than an actual site at which we've implemented these measures.
So, okay. So I think it is time to wrap up this webinar. So first of all, thank you, Martin. Thank you, Joe, for presenting. And thanks to all attendees for listening and posing the questions. The presentation and the recording of the webinar will be made available from the websites of both projects soon. In your screen, you probably see a survey. So if you have a minute to spare before logging off, please vote the 3 questions that you see. So that is all from my side. So I hope you have a nice evening.